Kc for this reaction CaCO3 in solid state. Can you write Kc for this? The expression of Kc for this reaction. Can you write it?
CaO into CO2 over.
Okay, you are going to write it like Kc will be equal to CaO and CO2 upon CaCO3. Always remember pure liquid, for pure liquid and pure solid, we don't write in expression of Kc. Always remember it. So what with this will be wrong. So what will be the value of Kc? So it will be basically CO2 only. Is this clear?
Yes.
Now, what will be the value of Kp for this reaction? So it will be PCO2. As you know that gases can be compressed, but solid and liquid are already compressed. So in in the expression of Kp, what I want to say is that in expression of Kc, we consider in aqueous as well as gas, but in expression of Kp, we consider only gases. Is this clear?
Yes.
So I'm going to give you a question. Wait a minute. Write the expression for Kp and Kc as well. CH3COO C2H5 in aqueous solution plus H2O in liquid state will give CH3COOH in aqueous plus C2H5OH in aqueous. The physical state is very important. Okay, just write the expression of Kc and Kp. Are you done with Kc and Kp?
All the states are in liquid, so they are all incompressible, right?
What I told you is that liquid, for pure liquid and pure solid, we ignore it because we consider it a value as 1 in pure liquid and pure solid. The value of Kc is expressed in physical state of aqueous as well as gas. So here is aqueous C2H5OH or CH3OH. So we will consider it. Are you getting my point?
Yes.
C2, wait a minute in this.
What is the difference between liquid and aqueous?
Basically, aqueous is, you can say it is concentrated, and liquid is that is solvent, that is very dilute. Okay. This is the difference. We won't write the expression of H2O in this molarity because it is pure liquid. When we are going to write Kp is not defined for this reaction because Kp is only defined for gases. Okay.
Okay.
Just write it and let me know. Kp is not defined, you can write. Done.
No.
Okay, let me know when you are done. Wait a minute.
Done.
Now, Fe plus 3 aqueous plus 3 OH minus aqueous will give FeOH whole thrice solid. Can you write the value of AK expression of Kc and Kp?
One over Fe plus 3 into OH minus raised to 3.
Raised to the power
3.
What about Kp? Kp is not defined.
Yes.
Very good. Now see, write a topic. A relation between Kp and Kc. In a reaction AA plus BB, there is, it will give Cc plus Dd. For this reaction, there is a relation in Kp and Kc. Kp is equal to Kc RT raised to the power delta Ng, and delta Ng is basically number of moles of product, gaseous product, minus number of moles of gaseous reactant. If I'm going to ask you, this is all in gaseous state. Can you find the number of value of delta Ng? What is delta Ng? Number of moles of gaseous product. What is the number of moles of gaseous product? 2 minus number of moles of gaseous reactant. Total number, this is also in gaseous state, this is also in gaseous state. So basically 1 plus 1, 1 plus 3, it will be 4. So the value of delta Ng will be minus 2. Are you getting my point? How to calculate delta Ng?
Yes.
We don't count aqueous or solid, aqueous or yes, aqueous, the one which is in aqueous state, aqueous solution. We don't count that number of moles. We count only number of moles of gaseous product minus number of moles of gaseous reactant. Now see how this relations comes.
What is P?
P, this P.
T. No, RT.
Okay. R is basically gas constant. You already know about it. From states of matter 8.314, 0.081, and T is temperature.
Okay.
I'm going to derive this formula. You wrote it.
Yes.
You are done with this.
Yes.
Okay. See how we are going to basically establish a relation between Kp and Kc. AA plus BB will give Cc plus Dd. These all are in gaseous state, that is by default. Okay. So if you are going to write the expression of Kc, it will be C raised to the power C and D raised to the power D upon A raised to the power A and B raised to the power B. Okay.
Okay.
Now see, in this container, basically all these four are present: A, B, C, D. So if we are going to apply, A is different gas, B is different gas, C is different gas, D is different gas. And we know that these all gases have same volume. Is that clear? The volume of gas A is equal to the volume of gas B, equal to the volume of gas C, equal to the volume of gas D, which is equal to the volume of container. Okay. Now we are applying ideal gas equation on each gas, PAV, because volume is equal equals to number of moles of A, R is constant, temperature. Since all gases are present in the same container, they will have same number of moles. Okay. No, sorry, they will have same temperature. Okay. Now see, if you are going to apply on B, it will be NBRT. If we are going to apply on C, it will be NCRT. Are you getting my point?
Yes.
NDRT. Okay. Now see what this CD square bracket represents. That represents molarity. Okay.
Okay.
That is molarity. I told you that this square bracket is basically concentration, and the concentration which it represents is molarity. Now I'm going to apply like PA will be equal to Na upon V into RT. Can I write this?
Yes.
Now see, number of moles per unit volume is molarity of A. Okay. Number of moles per unit volume, that is called molarity. And since number of moles of A, we are talking about A, so it is molarity of A, concentration of A. Akifah?
Yes.
So can I write it? PA will be equal to molarity of A into RT. Can I write this?
Yes.
In the same way, can I write this? PB will be equal to BRT.
Yes.
And PC will be equal to CRT, and again PD will be equal to DRT. I can write this
Yes.
as similar as we did for PA. Now, what I'm going to do is writing the value of Kp for this reaction. Kp, what is Kp? Partial pressure of C raised to the power C, partial pressure of D raised to the power D upon partial pressure of A raised to the power A and partial pressure of B raised to the power B. Okay.
Okay.
Now you can see the value of A, B, PA, PB, PC. Can I put this value on in the place of PC, PD, PA, PB? Can I put it?
Yes.
Now going to put the this value that is Kp will be equal to RT. This is the value of PC, and in the expression of Kp you can see PC has a power C. In the same way, sorry, D. Let me clear it. If I wrote it C first, that's why I'm writing it. This C, and there are power C. In the same way, this will be D RT raised to the power D. In the same way, A RT raised to the power A. In the same way, B RT raised to the power B. Can I write it?
Yes.
Now you can see RT is common. RT is for everyone. And I can write it Kp will be equal to This is basically, can I write it C raised to the power C and D raised to the power D, and here RT raised to the power C, RT raised to the power C into RT raised to the power C D, that will be C plus D.
Yes.
And in the same way, can I write it A raised to the power A and B raised to the power B, and here RT raised to the power A plus B. And in similar way, we can write C raised to the power C, D raised to the power D, and A raised to the power A and B raised to the power B into RT raised to the power C plus D. C plus D is what? Number of moles of product. Okay. Minus A plus B is what? Number of moles of reactant. Are you getting my point?
Yes.
Now you can see, you can see this is the value, this is the expression for Kc, isn't it?
Yes.
So can I write it? Kp will be equal to Kc RT raised to the power delta Ng. And what is this delta Ng? Can I write it? Wait a minute. Can I write it as C plus D? That means number of moles of gaseous product minus number of moles of gaseous reactant, which means Kp is equal to Kc RT raised to the power delta Ng.
Yes.
So here they here the formula comes. Here is the derivation for Kp is equal to Kcrt raised to the power delta Ng. Please write it and let me know if you are finished with this. Are you done with this?
No, one second.
Okay, let me know.
Can you scroll down?
Yes.
Done.
Very good. So now we are going to discuss after this. I'm going to take three cases. Case one, in which delta Ng equals to 0. I'm going to take an example of H2 in gaseous state plus I2 in gaseous state will give 2Hi in gaseous state. Okay. So here, if you are going to calculate delta Ng, that is number of moles of product minus number of moles of reactant. That is number of moles of product will be 2 minus number of moles of reactant will be 1 plus 1. That will be equal to 0, right? We are
Yes.
going to find a relation between Kp and Kc. Kp is equal to Kc RT raised to the power delta Ng, and Kp will be equal to Kc RT raised to the power delta Ng. That is our, what is the value of delta Ng? 0. Okay. So anything has a power 0 will be equal to 1. So Kp is equal to Kc. So whenever there is a question about Kp and Kc, which one is greater and which one is lesser, you have to answer it carefully. If delta Ng equals to 0, you just need to see the equation and find the value of delta Ng. Then you will get the value of delta Ng, and you can easily predict whether which one is greater and which one is whether they are equal or greater or less than to each other. Okay. So, so basically this was the first case. I'm going to take it the second case, delta Ng greater than 1. I'm going to take an example. PCl5 is converted into PCl3 plus Cl2. All are in gaseous state. I told you. And now you know that. What is the value of delta Ng, Akifah, here? What is this told?
1.
1. What is basically, this is product, that is 1 plus 1, and this is the reactant 1. So if you are going to apply Kp is equal to Kc RT raised to the power 1. Now you know the value of Kp is equal to Kc into something. That means Kp greater than Kc, right?
Yes.
Are you getting my point?
Yes.
Now the third case is that when delta Ng less than 0, that we are going to take an example of N2 gaseous state plus 3H2 gaseous state will give 2NH3 in gaseous state. So if we are going to find out the value of delta Ng, that will be equal to -2, right?
Yes.
And Kp is equal to Kp equals to Kc RT raised to the power delta Ng, that is -2. Now you can see Kp has the value after we divide Kc by RT raised to the power 2. Can you conclude it that Kc is greater than Kp? Yes or no?
Yes.
So whenever delta Ng equals to 0, that means Kp is equal to Kc. Greater than 0, that means Kp is greater than Kc. And less than 0, that means Kc is greater than Kp. Write it and let me know if you are done with this.
Can you scroll down?
Yes, fine. Just write it.
Done.
Akifah, are you done with this?
Yes.
Do you have any doubt in this?
No.
No, we have stoichiometry of reaction, or you can see characteristic of equilibrium constant. You can write characteristic of equilibrium constant. Characteristics of equilibrium constant. See, if we have a reaction A that is converting into B has a equilibrium constant K, then what is the equilibrium constant if we just reverse the equation? The equilibrium constant for the reverse reaction is, is inverse of its original equation.
Okay.
Got it? If we have
Yes.
some reaction that has the value of K given, and if question is asked when it reversed, then it will be inverse of the original reaction. Okay. Now, the second one. If you have a reaction, a reversible reaction, and it has a equilibrium constant K, and if you are going to multiply the whole equation by a number, whether it is n or 1 by n, anything, any number, you are going to multiply the whole equation by this. The new equilibrium constant for this reaction will be the power of original equation. Got it?
Yes.
Can you answer me if have if you have a given reaction that AA plus AA plus BB will give CC plus DD as an equilibrium constant, that is K, and not just don't write A plus B, and now we have a reaction N by Na plus, wait a minute, please write it, then I will give you the question. You done with this?
Almost.
Okay.
Done.
Now, the question to ask that N2 plus PH will give 2NH3 has the equilibrium constant K. Now, calculate equilibrium constant for NH3 will give 1 by 2 NH2 and plus 3 by 2 H2 for this reaction. Can you calculate?
One by K raised to
Very good. What
1
we
by
just
2.
did is basically just reverse it, so it will be 1 by K, and after reversing we divided by 1 by 2, so the value will be 1 by under root K, isn't it?
Yes.
Very good. Now the third characteristic, if we have something, we have a reaction, A is giving B, C is giving D. Now this has a equilibrium constant K1 and this has a equilibrium constant K2, and if we are going to add this equation A plus C, that will give B plus D. So the equilibrium constant for this reaction will be the multiplication of every reaction of equilibrium constant which comes to get together to give this reaction. Is that clear?
Yes.
Just write it. On Tuesday we will start ionic equilibrium.
Done.
Very good. Now we are going to study about Lee Chatterjee's principle, which is very important. Chatterjee's principle. What does this principle means? I'm going to write, then I will explain it. Write with me. It states that change in any factor that affects change in any factor that determine the equilibrium condition of a system will cause the system to change in such a manner manner so as to reduce or to counteract 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 the effect of change. So basically, if a system is in equilibrium and with some external effort that determines equilibrium, basically if you are going to change or if you are going to apply some external external agent, like if the system is in equilibrium and you just add some reactant, the system will adjust itself in such a way that it nullify the effect of external agent. Just write it and then I will take example and then I will explain it.
Done.
Okay, just see if a reaction, this reaction is basically in equilibrium. Okay, this system is in equilibrium and now you are going to add the concentration of reactant at equilibrium. You know the uh, basically concentration of reactant and product are constant at equilibrium, and if you are going to add some reactant in this reaction in this process, so you just increase the value of concentration of reactant. Okay, so in order to nullify this, the reaction or the equilibrium will shift towards right, so that it can divide and it will be again in equilibrium. Are you getting my point?
Yes.
Again, if you are going to add some concentration of B, so what will happen? Like it will shift towards left. Okay. Okay, just write it. Wait a minute. Can I change the slide? Are you done with this?
Yes.
Okay. So we are going to take it as a case and then write it. Case 1 is effect of concentration. Effect of concentration is like reactant is converted into product. The reactant concentration of reactant increasing, the product will the equilibrium will shift towards right. And if you are going to decrease the concentration of reactant, it will move to the left. Okay. Again, this is for one case 1, and case 2 is basically effect of pressure. Just see how pressure acts. N2 gaseous state plus 3H2 gaseous state will give 2NH3 gaseous state. To apply Le Chatelier's principle of effect of pressure, we need to calculate the value of delta Ng. Delta Ng will be -2, right? And you can see number of moles on the left hand side is 2 and number of moles on the right hand side is number of moles on left hand side is 4 and number of moles on right hand side is 2. So if you are going to increase the pressure, the equilibrium shift towards that side where number of moles is lesser. Are you getting my point?
Yes.
Whenever you are going to increase pressure, when a process or when a system is in equilibrium, the equilibrium will shift towards that side where number of moles are equal. Where number of moles are lesser. If you are going to take an example of PCl5 will give PCl3 plus Cl2, and you are going to increase the pressure, where will be the direction, left or right? Towards left or towards right?
Towards left.
Left, because number of moles on the left hand side is 1 and here it is 2. Again, I'm going to take another example. You can see H2 plus I2 will give 2Hi, right? So you can pressure where it will move. Pressure does not affect. Pressure will not affect. Pressure does not affect. Okay, when number of moles on the both sides are equal, pressure does not affect on equilibrium. Okay. Okay, just write it. Should I slide it up?
No.
Just write it and let me know. Are you done with this?
Yes.
Okay, very good. Now, effect of temperature. This effect of temperature depends whether the process is endothermic and exothermic. So we are going to take an example of endothermic first. Endothermic process. As you know that endothermic process needs heat. Okay. Heat energy endothermic process is the process in which heat is required and a reaction is converting into A plus A is converting into B, reversible reaction. And if you are going to increase the temperature, as this temperature is the favorable condition for endothermic reaction, so it will move towards right direction. Akifah, got it?
Yes.
And exothermic process, you already know about it. The process in which heat is evolved, that means it already has heat, it doesn't require any heat. And if you are going to increase temperature in exothermic reaction, it is not favorable condition for exothermic process, so it will be backward. Okay. Just right.
Done.
Very good. Now see, there is a term which is called reaction quotient. And reaction quotient is denoted by QC. It is denoted by QC. And what is QC basically? It is also a reaction constant, but it is other than equilibrium. Other than equilibrium, that means when we write Kc, this represents the system or the process is at equilibrium. Got it? Kc is for at equilibrium, and this Qc is for any time. Okay, so if we are going to write A plus B, C will be converting into D, and you are going to write, if I'm going to write Kc, so this basically this represents the system is in equilibrium. And if you are going to write the value of Qc will be written in the same way as we wrote for Kc. Okay, now basically this Qc tells the direction of equation, direction of reaction, where it will go left or right. So basically, if I'm going to write a relation between QC and KC, QC is lesser than KC, then it will go forward. QC is equal to KC, that means it is at equilibrium. And if QC is greater than KC, that means backward reaction. Got it?
Yes.
Just write it. Are you done with this?
No. Done.
Very good. So basically, according to deleted syllabus, our syllabus is completed, but you have to practice question. Do you have NCERT?
Yes.
Do you have NCERT? Okay. So I have some questions you have to do it. We will discuss it next class first, then we will start ionic equilibrium. So basically, right question. It is from exercise 2, 3, 4, 5, 6, and here is another question that is 13. Okay, so you need to do
Okay.
this question, this three fifth question. Do you have any doubt?
No.
So we are going to study about ionic equilibrium in the next class. We will start in the next class, and by the end of the coming week, we will complete our syllabus. Like, what is the date today? 6. Almost on 13th of March, we will complete our syllabus. Okay.